Hello, this is Professor Jim Caffey coming to you again, and today on this OpenStax Astronomy textbook lecture, we're going to cover Chapter 10 on Venus and Mars. Here is the Spirit rover on Mars in 2004, and you can see the tire tracks made on the surface of Mars. My former NASA intern now lands these rovers on Mars. Pretty neat that she does that. We have seen Venus from an orbiting spacecraft decades ago, and that was called the Pioneer Venus Orbiter. And what did it find? It found lots of clouds. This was an early attempt to see Mars from the surface of the Earth, and that was in 1988. You can see it has polar ice caps. Percival Lowell observed a lot of different objects in the sky. He has a Lowell Observatory named after him up in Flagstaff. And I will tell you this. You need to do a big event lab, such as an open house at the Mojave Community College Observatory, or at Kitt Peak National Observatory in Tucson, or maybe Lowell Observatory up in Flagstaff. They are big on education events, and if you decided to go to Flagstaff for the day, you could hit up Gale Crater and the observatory if they're open. They do research there, but you can try to see if you can get into one of those. And I will be trying to post when I find out any dates that the MCC Observatory is open. So here is Percival Lowell at his observatory in 1914, and that is really how we used to do it back then. I have done it myself as late as 1996. A better image of Venus comes by radar, and this was an image from a spacecraft. Impact features on Venus look very different than anywhere else. These features you see up here are pancakes. Pancakes, let me go back, we can see it here. These lava pancakes formed on Venus. The atmosphere on Venus is so tremendous and thick that you don't get peaks of mountains or even lava flows. They just flatten out. There's so much pressure in the atmosphere. The atmospheric pressure on Venus is 90 times more than what it is on Earth. Pretty intense. Here are some ridges and cracks in the surface, very detailed and a very young surface. Now, the United States hasn't sent a lander to Venus. We did the Magellan spacecraft to orbit it in the 1990s, but the Russians have been to Venus a couple times. Now these are real images of a foot of the spacecraft on the planet of Venus, and it looks like flat rocks, as I was describing those pancake domes. Those spacecraft burn up pretty quickly. So in Venus's atmosphere, it's got lots of carbon dioxide, sulfur. This is what drives greenhouse gases, carbon dioxide, and warming up of an atmosphere, whether it's on Earth or Venus. Mars, taken with the Hubble Space Telescope in 2001. Really good picture here. It was taken as Mars was near one of its closest points to us. You can see these blue thin clouds in its atmosphere, and Mars only has 1% the atmosphere of the Earth. Our first rover on Mars was Pathfinder in 1996, and it had a little bitty ramp to go on to the surface. Didn't do much science, but it proved that the technology to get us there worked. Here are some beautiful craters on Mars, Victoria Crater. We have gone into this crater with a rover to take these kinds of images. We do even have meteorites from Mars, and it's also basalt like the moon, and this actually arrived on Earth. We don't know of many, but we do know of about 3 dozen. You can use lasers to measure the altitude of things on Mars, and we can see the largest volcanoes that it has. And of that, Olympus Mons, Mount Olympus, is the largest volcano in the solar system that we are aware of right now. It makes Mauna Kea in Hawaii be dwarfed by this thing. This Olympus Mons on Mars is a dormant, extinct volcano, and you can fit the entire state of Arizona right on top of that volcano, and it would not be completely covered up. Bigger than the entire state. We have massive canyons on Mars. This Valles Marineris, Mariner Valley, stretches 3,000 miles across. It makes the Grand Canyon look like dust. It is so huge. It goes all the way across the United States, if you could put it on our map, and much deeper than the Grand Canyon. We have seen landslides in some of these craters on Mars, and out of some we find evidence of water pouring down. You can see these streaks here. This is evidence that liquid water has come through the wall of that crater underneath the Martian surface, and it comes out in the crater and evaporates quickly. Here are 3 landing sites that we explored early on with Viking 1 and Viking 2 and the Pathfinder rover. There's going to be a 2020 Mars rover in space. We can find frost on Mars' surface. That is frost there. We even see dust devils and sand dunes on Mars. These dust devil tracks, about like what we see in the desert of the United States. We can even find wind erosion because there is an atmosphere, a small one, but it is there, it's thin. The 2 ice caps are different. One is water ice, one is carbon dioxide ice. We have even seen ice just underneath the surface by an inch. We dug for it with the Phoenix lander at the North Pole area, and it found permafrost right underneath the dust. We find runoff channels and outflow channels and boundaries like you would see in the Mississippi River or the Colorado River. We see gullies, like I was describing to you before, but this is much better. Water coming out of those gullies. More evidence for liquid water on Mars are these streaks from this mountain and crater. And here is Gale Crater, where the Curiosity rover landed and has been for years working. Now, you may have seen this. This is the infamous face on Mars. And some people will say that it is evidence of an alien civilization. We have actually mapped this since 1976, and the new image over here looks like this, at much higher resolution. It does not look like a face to me. Well, guys, that's going to do it for Chapter 10. Thank you for joining me, and I hope to see you on my page next time around for Chapter 11. Thanks.